Let's talk domain, range, and blenders. First of all, if you haven't watched my video on what is a function, then click on the link on the top right. There's no point in trying to find the domain and range of a function without even knowing what a function is. It's only about 3 minutes long and you'll understand everything a lot better if you watch that one first, especially while we're using a blender. Also, if you're only using this video to learn about range, then feel free to skip ahead using the chapter markers below. Let's make this blender our function. In order to be a function, each input can only have one output. So everybody's happy using the blender, putting in different inputs, getting out different outputs, until that one person tries to make a smoothie out of a rock. Yeah. So it turns out that our blender function can't just take any old input. It can only take inputs that can be blended. And this is where we talk about the domain. The domain is the set of all possible inputs that produce a defined output. For our blender function, the domain is the set of all blendable objects. For example, a banana. People use blenders to make all kinds of things like smoothies, sauces, and my personal favorite, milkshakes. The ingredients for all of these things are in the domain of a blender. Rocks, however, are not. Let's look at an example with numbers. On this board, I've drawn a square with side lengths of x. The area of this square is given by our function a of x equals x squared. We know that our input is the side length and our output is the area. Since the domain is a set of all possible inputs that produce a defined output, it is describing the possible side lengths. The only issue that we could have with the inputs is if they're negative. For example, if x equals -3, this doesn't cause any issues in our function since we can still plug it in and get an output of 9, but it doesn't make sense in the problem since x is representing the side lengths of a square. A square with a side length of -3 just doesn't make any sense. Because of this, our domain will not include any negative numbers. Instead, our domain will be all real numbers from 0 to infinity. Now, people might also argue that you can't have a square with the side length of 0, so it's probably best to not include 0 in our domain. Oh, by the way, if you're at all confused about what I was just writing, that's called interval notation, and there's a link on the top of the screen right now that takes you to my video on interval notation. If you don't know what it is, I'd recommend watching that video and then coming back to this one because I'm going to be writing all of our answers in interval notation. Now, when we're looking for the domain of a function, there are two very common domain restrictions. The first is if we take the square root of a negative number, and the second is if we end up dividing by 0. Let's look at this equation. Since there's a square root, we want to be on the lookout for any x values that make x plus 7 negative. In other words, our domain will be the x values that make x plus 7 greater than or equal to 0. When I solve this inequality, I get that x has to be greater than or equal to -7. And in interval notation, that looks like this. Let's look at another example. I notice right away that this function has a fraction, and I want to avoid dividing by 0. In the last example, we thought about what x values do work, and in this example, I want to think about what values don't work. So, I know that I don't want the bottom to equal 0. So, to do this, I'm going to say I want to say that x minus 4 cannot equal 0. When I solve this, we get that x cannot equal 4, and that's our domain. Go ahead and pause the video and try to write the domain in interval notation. We're finally ready to talk about range. Range is simply the set of all possible outputs. Since an output has to come from an input, the range depends on the domain. Let's go back to the blender. Our blender can only produce blended things. They can't make things like textbooks or blankets or rock smoothies. And that's where the range depends on the domain. Rock smoothies aren't in the range because rocks aren't in the domain of the blender. Something similar happens with the area of the square. Since the area is the output and the range is the set of outputs, our range is going to be the set of possible areas of the square. Since we find the area of a square by squaring the side length, we're never going to get a negative number for area. So our range is going to be from 0 to positive infinity. Another way to think about it is since our side lengths cannot be negative, and our domain says we can only have inputs from 0 to infinity, our range is going to be the set of outputs based on those inputs. So since we're inputting only positive numbers, when we input positive numbers, they get squared and out comes positive numbers from 0 to infinity. If you were at all confused about the interval notation in this video, I recommend watching this video where I go over what it is and how to write it. If this video was helpful to you, please feel free to leave a like, and if there's any other topics you want me to cover in the future, go ahead and leave a suggestion in the comments. Thanks for watching.